All right, in this example, we are asked to use limit notation to describe the end behavior for these functions. Now, we've really already done it for e to the x. Part A is e to the x. And we showed in the first problem that the limit as x approaches infinity of e to the x is equal to infinity, right? As we approach, as x gets larger and larger and larger in the positive direction, then e to the x just gets larger and larger and larger to infinity, okay? Now, the other part of end behavior is what happens as x goes toward the other end of the x-axis, right? So we're looking at the limit as x approaches negative infinity of e to the x, okay? So remember when x is negative, this is essentially the reciprocal, and so we're dividing 1 by larger and larger numbers, and we found in example 1 that this limit goes to 0, okay? So that's how we describe end behavior. We look at the limit as x goes to infinity and x goes to negative infinity, usually. All right. So, but let's go ahead and look at the next one. Then this is e to the minus x. So what does that do? So it's basically going to flip this graph around, right? It's going to reflect it across the y-axis. So as let's look at the positive case first, the limit as x goes to positive infinity, all right? And it's e to the minus x. So this is effectively the same as the limit as x goes to infinity of 1 over e to the x. This is the same thing. So as x goes to infinity, this is just going to go to 0, right? We're just dividing 1 by bigger and bigger numbers. Just like in part A, when we went to they just looked at the limit as x approaches negative infinity of e to the x. Okay. All right. So now the other end, what happens as x approaches negative infinity? Okay. So again, it's just a reflection of the e to the x function. So as x goes to negative infinity, we get, we're putting in negative numbers for x, so we get e to larger and larger numbers, so it's just going to be infinity. Okay? All right, now, how do we describe the end behavior for the natural log of x? Now, we looked at the natural log of x in example 2, and we saw that as x gets larger and larger in the positive direction, then ln of x gets larger and larger. So we can say that the limit as x approaches positive infinity, and we're going to do ln of x, that just goes to infinity. Now it grows very slowly, but it does go to infinity. All right, so now we need to look at the other end of the domain. All right, now remember that the domain of the ln of x doesn't go to negative infinity, right? Remember the domain, the left end of the domain is 0. So let's look at the limit. Let's do the limit as x approaches 0. Okay, but we want to approach it from the right, from the positive side of the axis, because we can't approach it from the negative side of the axis, right? ln of x is not defined at 0 or any negative numbers. All right, so we're just going to look at the left end of the domain, which is 0. We're going to approach it from the right. So what happens as we approach, as x approaches 0 from the right, we get negative infinity. All right, so that's how we describe end behavior. We look at the ends of the domain, essentially, of the function.